All right, folks, welcome. Thank you all for coming out. Last topic here today on day 3 of the second annual World Conference. My name is Emmett. I'm just the announcer today. Give it up for Nicholas Scott, developer at Nagios. Nick Scott is a member of the tech team at Nagios Enterprises. He attends the University of Minnesota studying electrical and computer engineering. And in his free time, he enjoys hacking in Python and taking things out of context, as well as analytical number theory. Give him a big round of applause.
Hello, everybody. As you may have gathered, I'm Nick, and we're going to be talking about data analysis today. It should be kind of interesting. I just want to give you guys a forewarning. Math might occur later, and if you're more into the application, you're looking for how this is going to directly apply to what you want to do, I'm not trying to get you guys to leave, but you might be happier at Wittenberg's presentation, which is fantastic. So just giving you a heads up there. But also, there's going to be some stuff on the screen. And anyways, I also want to say that, while I do like statistics, I am not a hardcore statistician. So if there's some hardcore statisticians in the room, we can talk afterwards. All right, so anyways, I'm going to try and stick with the actual application and maybe the ideas behind the actual data analysis going on, but I might foray into some programming stuff behind what the actual implementation of what I've done is. So with that in mind, we'll move on. Can everybody hear me? This is good volume? All right. So the things I'm going to cover today, I've already done the introduction, which kind of seems strange that I would put the slide after that, but I'm going to go over the capacity planning component that is going to be part of Nagios XI 2012. I do believe Mike Guthrie covered it to a small extent in his, but I'll be going over it a little deeper. Some of the features that it has, the different forecasting methods, when you should use these forecasting methods, just stuff like that. And then I'm also going to delve into something else that I just kind of wrote up for this presentation, an RRD analysis tool. I won't explain that too much because I'm going to explain it later. But so in that regards, we'll just move on here. So the thing about Nagios is you have this server that is running all the time, and it is recording everything it gets. Well, now it is. I mean, maybe back in Nagios 1, Nagios 2, it just kind of would get the data, display it, and then poof, it's gone. But now it records all of that perf data into an RRD file somewhere. So you've got 3 years, I think, is the default for how much performance data you have. So you're kind of in a really nice position that not a lot of other not a lot of other professionals are in, where they have this performance data historical for just so far back. It's crazy, and it's all for you. And you can do whatever you want with that data. So that's good, but the thing is that there's so much of it. And I was talking about it in my last presentation, and this is actually kind of a pattern of what I'm presenting on and perhaps what I'm interested in, is that how to turn all of that data you have into something actually useful. So hopefully we'll get to the bottom of that. Maybe we'll just make it even more complex. Sometimes that happens. The other thing about the data you're getting is that it's generally very noisy data. And when I mean noisy, it doesn't really cut straight to what the root of what the ping actually is. Usually ping is not steadfast. It's never a solid 40 for the entirety of its lifespan, or it's just noisy and you have to smooth it. And the thing is, when you're doing statistics, you don't really want noisy data. Noisy data is bad. So we're going to go over ways to smooth that out. The other thing is that sources are usually not simple. Yeah, I guess I just wrote it up here. How many factors are affecting service X on a given host Y? What is causing the current load on some server? Is it that simple? There's so many subcomponents of that current load that it's not easy to break down. So each service is a complex function. How would you write a function, some function as a function of however many variables you want it to be to represent what the current load is? If you think about that, oh, well, maybe it's the activity of the MySQL database and how many hard drive writes it's doing and just some function of all of these. But after thinking about it, you just kind of realize how big of a scope that it is, and also maybe how how fruitless that might actually be. So I guess my point is that when I go for analyzing data, I try and get the actual like subcomponents out, because that way you can actually make a decent forecast or reasonably explain what the data is doing and why it's doing. But with such dynamic systems like the computer and the network systems, it's almost impossible to actually get all of those factors out. So the goal is to make all the data usable, and that's kind of the heart of forecasting and analysis and understanding the numbers better. So what we're going to talk about might seem a little abstract at first, but hopefully it'll present itself as something that's maybe useful and maybe something to do on Friday and Saturday nights. So okay, so I'm just gonna there's just two words. I'm just assuming that you guys don't know a whole lot about statistics or whatever, and I'm just gonna there's only two words that I'm really gonna use that you're gonna be like, what does that mean? It's residuals. Residuals are points on a graph that don't fit with the actual fitted function. Like on this thing, like if I had a bunch of points that were like dot 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 dot, and I found some fit that was just the cosine of some function t, the actual residuals are like, if there's a point up here, it would be like the sum, like the variation that exists after fitting. And so if like there's this, it would have a residual value of that much. And then a period is a frame of time where a pattern cycles through a completion iteration. So I'm actually going to go much deeper into periods later, but obviously on this, like, it starts here, it makes a complete cycle and comes back up, and the actual next pattern is going to be the same way. So it's got a period of 2 pi. I'm just using this function because I'm pretty sure most people are familiar with sine and cosine waves. So that's just a period. So when I do say period, that's pretty much exactly what I mean later. All right, moving on. We're going to watch a video. Let's get hype. And it is on. It is right. Oh, here we go. Awesome. Okay. Oh, okay. Here we go. All right. So now I'm going to actually go into a little bit of application and like some concrete examples of what's going on. This is the non-maximized video. Okay. This is the Nagios XI capacity planning component. And I'm just going to go through and show off some of the features of what it does, just show you what it can do. Then I'm going to go back and I'm going to kind of explain maybe what it does and how to do stuff with it and how to get some actual useful information for you if you ever use it. It's basically, you just kind of point it at a host and you point it at a service. And when you point it at a host, it's going to populate all the services that are possible. You might have some checks running that are not like returning perf data, so it doesn't really even store an RRD. Like, I don't know why these don't return perf data, but they're not. But it does go through the actual RRD, so you're not going to try and forecast stuff with a bunch of not a number RRDs. And you pretty much select it, and it kind of graphs what's going on at this current time. And if you pick one, it works much like any other perf data. Like, see, this one actually looks interesting. And it would be good for forecasting. And then here, where we're at, is we go into the extrapolation options, because that is ultimately what we're trying to do here is make it so that you could do capacity planning. Because, like, here is 2 weeks ago, and then here is today, I think as of like 7 this morning. And then we want to be able to calculate what's going to be like over here, whatever the value is going to be. So we had to pick these options. Now, I said a period. Like, a period is the cycle, or the actual time that it takes for a cycle to complete and then go back to a similar point in time. I kept this at weeks because I think generally networks do function, like, run with a period of about a week or some multiple of a week. I couldn't really think of a better way to do it. That is actually on my to-do list for this, is to actually run some sort of test to find the periodicity of these, but currently that's not implemented. So you just kind of pick one of these, and I think you'd be safe picking pretty much any of them. This will actually dictate how far out you can